Okay, again, I'm hoping that we completed 5.2 before you left for camp, but just in case we didn't, I will do some practice problems. Again, you should watch the introduction video that covers these two sections in terms of the concepts. So the idea of a perpendicular bisector: if a point lies on the perpendicular bisector of a segment, then it is equidistant from the segments. So I know this is perpendicular bisector, therefore B must be equidistant from A and C. So 2x equals 5x minus 6. Solve for x, but don't neglect the question. Find the length of AB. So in this case, I would get that 3x equals 6. So x equals 2. So 2 times 2 is 4. 5 times 2 is 10 minus 6 is 4. So that checks out. Same thing here. Set them equal to each other because, again, I'm on the perpendicular bisector. And same here. Set them equal to each other, solve for x, but then go ahead and find the length of the segment by substituting back in. And it is a good check to plug it into both and make sure they're equal. Tell whether the information allows you to conclude that C is on the perpendicular bisector of AB. Well, I know C is equidistant from the endpoints, so yes, it must lie on the perpendicular bisector. That's the converse. In this case, I know that these two sides are equal, but you can't say it seems like this is perpendicular. This could be slightly hinged there. So we don't know this is perpendicular, so in this case, no, not enough. Don't know. Perpendicular. Looks like it, but I like to say there's no it looks like it postulate. And then in this case, yes, C lies on the perpendicular bisector. So, yes. I don't even know why they asked that one. It's obvious. Use the diagram. EH is the perpendicular bisector. So again, I like to show that those are congruent. Find EF. So if EH is the perpendicular bisector, E must be equidistant from the endpoints. 7x plus 9 equals 9x minus 1. And then solve for x. So that's what a lot of those have to do. Again, you're just setting them equal to each other, but make sure you're thinking through the process. Here I'm told that these two are congruent by the tick mark, so I can set them equal to each other and solve for y. So that's how you can go about doing those things. And then I'm assuming once you find x and y, you can plug those in to find FH. I'm not sure practice A is going to have anything that complicated. The other thing about perpendicular bisectors is, if you remember, if I connect the perpendicular bisectors, and you can't see this one here, F is perpendicularly bisecting this segment, they meet at a point, the point of concurrency is equidistant from the vertices. So BG is equal to AG is equal to CG. The perpendicular bisectors meet at a point that is equidistant from the vertices. That's how you get that. That's how you can circumscribe a circle around that triangle. So they tell you to find AG. Well, I know that GC is 25, so it has to be 25. Find CF. Find BD. Well, here you'd have to use Pythagorean theorem. I know this is 25. I know that's 15. So a squared plus b squared equals c squared. So you could find GE. I'd just start finding. This is 20. I would just start finding all the ones I could find, and start filling those in. But yeah, you might have to use Pythagorean theorem. A squared plus b squared equals c squared. A squared plus b squared equals c squared. Oh, this has to be 25 too. So that's how you could go about finding those. This one asks you to do a little proof. I don't know that 5.1 practice A does, but just a good review. CD is the perpendicular bisector of AB. So that means this must be true. Prove triangle ACD is congruent to triangle BCD. Well, I know they share this side, so by SAS, those two triangles must be congruent. Triangle GHJ is congruent to triangle FHJ. Prove EF is congruent to EG. Well, the theme here is that if a point lies on the perpendicular bisector, then it must be equidistant from the endpoints. So if I could prove that this is perpendicular and these are congruent, then I could say E is on the perpendicular bisector. Well, since I know the triangles are congruent, GJ must be congruent to JF. Remember, by CPCTC, corresponding parts of congruent triangles are congruent. And these angles must be congruent. If I call them angle 1 and angle 2, angle 1 is congruent to angle 2, again by CPCTC, and therefore they must be right angles, and therefore they must be perpendicular, and therefore E lies on the perpendicular bisector, so EG must be congruent to EF. Probably easier to write a paragraph proof about that. Yeah, back here, I just wanted to backtrack a little bit. CF has to be 24 because this is 24, so that has to be 24. That's some kind of special right triangle, 24 something 25. I can't remember what it is. Let's solve it. 24 squared plus x squared, that being x, equals 25 squared. So x squared equals 25 squared minus 24 squared. 25 squared minus 24 squared equals 49. Aha! X squared equals 49, so x must be 7. So GF must equal 7. Although they don't ask me for it. But just the whole idea that you've got right triangles there. And good old Pythagoras. All right. Hopefully that goes smoothly.